Hello students, welcome to Spectra Education Academy. In this video, I am going to explain answers for very short answer type questions in the chapters both electromagnetic waves and dual nature of radiation and matter. Question number 1. Why are microwaves used in radars? So since the wavelength of microwaves is a short, which are used in radars and which is again in turn used in aircraft navigation. Moving to the next question. Question number 2. What are the applications of microwaves? So the microwaves are used in, first one is radars and telecommunications. The first application. Second, to analyze the details. Details of the molecular structure. Third, basing on the microwaves, speed guns are designed to increase the speeds of the balls while giving the service in the game of tennis. Then microwaves are used in microwave ovens, in domestic purpose to prepare food items. Moving to the next question. Write any one use of infrared waves. Which animal can detect infrared waves? So the first one is to take the photographs in fog. This is answer for question number 4. Second, in physiotherapy. Next, in military purpose. Also to observe growth of the plants or crops. Next, so the next part of the next question is which animal can detect? So sometimes snakes snakes of different kinds, and bats, even bats can observe the infrared waves. So moving to the VSAQs in next chapter, that is dual nature of radiation and matter. The first question is, what is photoelectric effect? The phenomenon of ejection of electrons from the photosensitive surface or metal surface. Photosensitive surface when light, photosensitive surface when light of sufficient frequency or wavelength incident on it. So this is called as photoelectric effect. Next question is, state Heisenberg uncertainty principle. According to the principle, it is impossible to measure both position and momentum of a particle simultaneously. Then delta x is the position, delta p is the momentum, nearly equal to h dash, or this can also be written as delta x into delta p is equal to h dash is h by 2 pi. So where h is Planck's constant, which is equal to 6.634 into 10 to the power of minus 34 joule second. Moving to the next question, that is cathode rays. Question number 3. So the cathode rays are stream of fast moving electrons in a discharged tube. When the pressure of the gas is at 0.01 millimeter of Hg and a potential difference of 1 kilovolt, otherwise 1000 volts applied between the two electrodes, of discharge tube. Then moving to the answer for next question, that is fourth, work function. The minimum amount of energy, required to liberate or to eject an electron from the metal surface Otherwise, you can write photosensitive surface is called work function. Next, question number 5. An electron and an alpha particle and a proton have same kinetic energy. Which of these particles has shortest de Broglie wavelength? So first write the mathematical form of de Broglie wavelength. So wavelength of matter wave is equal to h by mv. But don't forget to include kinetic energy in the expression. So get back the expression of kinetic energy, half mv square, because in the question they mentioned same kinetic energy. Somehow you managed to get kinetic energy in the equation. So therefore 2 into ke, m will come down, is equal to v square. If you want only v, you write under root 2 ke by m. So substituting that here. So h by m first with 2 into kinetic energy by m. So after you simplify, this is make it root m into root m with 2 into ke by m. So root m get cancelled. So finally you'll get 2 ke with m. So therefore lambda is inversely proportional to mass when kinetic energy is constant. Yeah. So get back the mass of the electron, alpha particle, and proton. Okay. You treat mass of the electron is 9.1 into 10 to the power of minus 31. Then whereas alpha particle is having 2 electrons. So therefore mass of the 2 electrons, it means 2 into E. So therefore it is of a positively charged particle. 2 into protons, you can say. Mass of the protons, 2 into 1.6 into 10 to the power of minus 27 kg. Whereas proton, it is just 1.6 into 10 to the power of minus 27 kg. Out of which mass of the electron is less. So therefore, if mass of the electron is less, its wavelength will be more. Out of which the mass of the helium, alpha particle, this is also called as alpha particle, is greater. So therefore, which possess short wavelength. So therefore, lambda of the alpha particle is less than lambda of the proton, and which is less than lambda of the electron. So mass of the alpha particle is maximum. Then it possesses wavelength less. Moving to the answer for next question. The wavelength of electromagnetic radiation. Wavelength of electromagnetic radiation is double. What happens to energy of the photon? Okay. Question number 6. So get back the formula. E is equal to h nu first. This is energy of the photon. You can transfer this equation as nu can be replaced with c by lambda, because c and nu and wavelength are related with this equation. Speed of light. There is also equation of speed of the radiation, its frequency and wavelength. So frequency can be replaced with c by lambda. So therefore, wavelength doubled. Wavelength and lambda are inversely proportional. E2 is equal to 1 by lambda 1 and 1 by lambda 2. So this is going to be lambda 2 by lambda 1. Then they mentioned in the question wavelength is doubled. So before we increase the wavelength, energy is E. We are looking for E2. Wavelength is doubled means 2 lambda and lambda. This and this get cancelled. So therefore, energy becomes E by 2. So reduced by 2 times. Moving to the next question. 7th. Question number 7. Write down the de Broglie relation and explain the terms therein. So de Broglie equation, lambda is equal to, so wavelength of the matter waves is equal to h by mv. In this, lambda is the wavelength of the matter waves, wavelength of the matter waves, And okay, so H is anyhow Planck's constant. Planck's constant. V is velocity of the matter wave. And mass is, M is the mass. Then moving to the question number 8. Write down the Einstein photoelectric equation and explain the terms in it. So the energy of the photon, E is equal to h nu, is utilized to liberate electrons from the metal surface. So that is nothing but work function. Also to provide kinetic energy to the emitted electrons. So that is kinetic energy. So in the other way also you can write h nu is equal to pi, this is the work function, plus half mv square. So here h nu is energy of the incident photon. Then pi is the work function. So half mv square is kinetic energy of the emitted electrons. Kinetic energy of the emitted electrons from the metal surface. Moving to the next question. Question number 9. What is the de Broglie wavelength associated with an electron accelerated through potential difference? So you have to get back the wavelength of the matter waves, mv, but it is not directly given v. So this velocity you have to turn in terms of potential. So the way is kinetic energy is equal to half mv square. When a potential difference of 1 volt, is applied between the two electrodes of the discharge tube, so they possess kinetic energy, which is also called as electron volt. So 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joule. So this is also called as kinetic energy. So now, first get the velocity in terms of kinetic energy first. So it is 2 ke by m is equal to first v square. We are looking for only v. So therefore lambda is equal to h by mv. So what is v here is 2 into kinetic energy by m. So taking this m as root m into root m with 2 ke by m. So root m get cancelled. So you'll get the equation 2m ke once again. So what is ke is electron volt, 1 electron volt. So but here they mentioned 100 volts. So you have to get electron into voltage, so potential. So therefore h is equal to h divided by 2m into kinetic energy is electron volt, charge of the electron with 100 volts. So let us substitute them. H is 6.634 into 10 to the power of minus 34 divided by 2 into mass of the electron. So 9.1 into 10 to the power of minus 31 kg. Charge of the electron 1.6 into 10 to the power of minus 19. And the potential is 100. So if you simplify this, you will roughly get, so 6.634 into 10 to the power of minus 34 divided by, this is 32. So you say this is 1.6 into 9. So 16 nines are roughly 144, but this is going to be 14.4. 1.6 into 9 times, so it's 14.4. 14.4 into 2 with 100. And power minus 31 minus 19 is going to be minus 50. Okay, so this is root 200. Yeah, make it 144. Then this is 20. So therefore 6.634 into 10 to the power of minus 34. So at the denominator 144, root 144, you can split the root when the quantities are in multiplication. So this is going to be 12 and 20. So 20 can be written as roughly 2 root 5. Then there is 10 to the power of 50. So you can make without root is 25. So this and this get cancelled. This will be minus 9. And this is 6.634 into 10 to the power of minus 9 divided by 24. Otherwise, you can make this as roughly 2.2, 12 into 2 with 2.2. Because root 5 is roughly 2.2. Close to 2.3, okay, 2.2. Then this is roughly 3 times. Then this is 4 times. So 1 by 8. So 1 by 8 means it will be 10 to the power of, make it 10 to the power of minus 10, so that you can write 10 divided by 8. So 1.25. So 1.25 into 10 to the power of minus 10. The question is to find out de Broglie wavelength. So therefore it is measured in meters. Okay. So the already answer of this particular question is covered, 10th one. Moving to the 11th. What is the de Broglie wavelength of a ball of mass 0.12 kg moving with a speed of 20 meters per second? So straightforward, lambda is equal to h by mv. So this is h is 6.634 into 10 to the power of minus 34 divided by mass. Mass is 0.12 multiplied with 20. So therefore, so we can make it 1.2. So this is going to be 2.4 roughly. 6.634 into 10 to the power of minus 34 divided by 2.4. Then okay, so 6.6 you can make is 1.2 once again. This is 3.3. So close to 33 by 12. So 33 by 12. 12 2s are 24. 7 left. Roughly 5 times, close to 6 times. 2.6 into 10 to the power of, not exactly 6, less close to 6. 2.6 into 10 to the power of minus 34. Minus 34 meters. So in the next class, let us continue VSAQs in the rest of the chapters, which are semiconductor devices and communication systems. Thank you very much for watching my video, but don't forget to share and subscribe with your friends and relatives.